Okay, what we want to have a look at now is our composite functions. Again, have a look at the theory notes on Ed Rollo, they're quite good. But really a composite function is a combination of function. It's a function of a function. So in here you can see that we've got the function f of x equals x plus 3 all squared. So what we're really saying is that could easily be a combination of h of x equaling x squared and g of x equaling x plus 3. So if I put in h of g of x, that means wherever I see an x, I put g of x. That's the same as x plus 3 being substituted into h of x, or if you like, h of x plus 3. So we call it a function of a function, or a function within a function. The notation, h of g of x, which is there, which we also sometimes call, you'll see it down here, h of g. So f of g of x, f of g, g of f of x, g of f. So that's the inside function, so it's g into f, or f into g. So if we have a look at a couple of examples. Here's my two functions, f of x and g of x. So let's just start with familiar. F of 3 means substitute 3 in for x. So that's equal to 3 squared minus 2, which is 9 minus 2, which is 7. F of g is f of g of x. So that means wherever I've got an x in f, so if you like, that's my function f, I need to put in g of x, which is 2x plus 1. So then if I expand that, I'm going to have 4x squared plus 4x plus 1 minus 2, which is 4x squared plus 4x minus 1. Okay, so there's my function f of g. So then f of g of 2 is really substituting 2 into all of that. Which is equal, 2 squared is 4, so 16 minus 8 minus 1, which is 7. G of f, on the other hand, g of f of x, so substitute f of x in for g. So g is 2 times x plus 1. Instead of putting x in, I put the function f. So that's equal to 2x squared minus 4 plus 1, which is 2x squared minus 3. And if I substitute a term in there, g of f of 2a, that's just substituting 2a into that function, which is 2 times 2a squared minus 3, which is 2 times 4a squared minus 3, which is 8a squared minus 3.